All right, guys, we're back at it. This is lesson H.08, and I am splitting this up into two separate lessons. So this is day one. Today we're talking about dot products. Dot products are an integral part of doing real matrix operations. So I just wanted to take this a little bit at a time. So let's just talk about the basics of what a dot product is. All right, given a single row or column and or another single row or column. So here I've got matrix A. It's just a single row of numbers, A1, A2, A3, dot, 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 up to AN, however many it is. And then I've got a second matrix, B1, B2, B3, dot, 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 up to Bn. Now, what's important is that each of these have to have the same number of elements in it. They could have both been rows. They could have both been columns. One could be a column, one could be a row, one could be a row, one could be a column. It doesn't matter. Okay, to find the dot product, AB, what you do is you just take A1 times B1, A1 times B1, and you add A2 times B2, and then you add A3 times B3, and then you add, and you do that all the way up to where you get to AN times BN. Now what's interesting here is that in the last video when we were doing the matrix operations, if you started with a matrix, you ended up with a matrix. But if you think about what a dot product is, you don't end up with a matrix. What you're going to end up with is a number. Okay? Because once you do all these multiplications and you add them all up, your final result is just a number. So here's an example. Zimbabwe. Okay, so I've got the matrix 6, 4 and the matrix negative 2, 11. So the dot product, and let me just point out that the dot between the A and the B is a little bit bigger than the dot when you use for multiplication. It's like that dot but in bold. But anyway, so to get the dot product of A and B, you just take the first entries and you multiply them. So 6 times negative 2 plus 4 times 11, which is negative 12 plus 44, which is 32. So there you go. Look, a dot product produces a number. All right. Now, sometimes I'm going to slip in a variable just to see how well you're paying attention. So let's look at this one. Example Congo. And I've got 3, 21, 14, and 3. That's my matrix C. And D is 7, Q, 4, Q. So if you think about it, what we're going to get is not a number. What we're going to get is an expression. But let's go through the product. So we take the first element of each, 3 times 7, and then we add 21 times Q, and then we add 14 times 4, and then we add 3 times Q. Okay, so that is 21 plus 21Q plus what's 1656 plus 3Q. Okay, combine the like terms. So that's 21 plus 56 is 77 plus 21Q plus 3Q is 24Q. All right, it's still this, you've got an expression here because there were variables in the matrix. Up here we got a number because there were no variables in the matrix, all right? That's a pretty simple operation. So that's all that's really new for today's lesson. But I have some things I really want you to think about, okay? So I'm going to leave this to you to consider. So questions to consider. Do dot products comply with algebraic properties? You remember all your algebraic properties? Commutative, distributive, associative, all those? Well, when we're doing dot products, do they comply with those algebraic properties? For instance, commutative property. Is A dot B equal to B dot A? I don't know. Distributive. Does A dot B plus C equal A dot B plus A dot C? I don't know, figure. What about associative? What about all the different algebraic properties that you know about? So I want you to explore those on your own and see what you can come up with. All right, real short lesson today, just how to do a dot product. If you can